Hi guys, my name is Ashutosh Relekar from Rajarampu Institute of Technology. In this video, I'm going to perform 2D shell, 3D tetra, and 3D hex mesh on 3 different components, so let's start. First, import the geometry. 2D mesh is used for analysis surface stress, boundary condition representation. First, split the surface using quick edit command to simplify the meshing surface. Then put the washer on the holes for better mesh quality using washer split command. Now start 2D shell meshing on the surface of the component using freeform command. Click on the Create, then select Surface and give the required element size. Then click on Mesh. Now adjust the element quantity for fine meshing. Then perform the same step for other side. To mesh this surface, use Face Edit command. Click on the Face Edit command, then select the surface. Choose the required parameters like type of element, type of surface to map, and type of mesh. Now to adjust the number of the elements. Select the density command. Here we can adjust the quantity of elements as per our requirement. After the mesh, check the quality of the element. Form Auto Quality command. Click on the Auto Quality command from 2D. Select the required quality and check elements. Here our 2D shell mesh is complete. Now let's start 3D tetra mesh. First, import the part for 3D tetra mesh. Now go in 3D and select TED icon. Then click on the solid and select the component. Then give the required element size and click on the mesh. Wait some seconds to complete the process. To check the quality of element, select the Edit option, and then click on Solid Mesh Optimization command as shown on screen. On this pop-up page, by clicking on the check button, we can see all the errors on the screen. Here, 3D tetra mesh is done. Now we start the 3D hex mesh. First, we split the surface for considering the boundary of the surface elements. Go on Topology and click on Quick Edit command. Then select Split Interactive option. Then we can directly drag the line on the surface for splitting as shown on screen. Now we split the solid for clear and fine meshing. By clicking on Split/Stitch command, click on Solid and select the component, then select the boundary lines to separate the solid as shown on screen. Perform same step for separating all the parts of the component. Now we can start 3D hex meshing on the component. For 3D hex mesh, go on 3D and click on Map icon, then select Create option. Click on Mappable Solid and select the solid as shown on screen. Give the required parameters and mesh. Now to adjust the number of the elements. Select the density command. Here we can adjust the quantity of elements as per our requirement. Follow the same procedure of 3D hex mesh for all the component. The 3D mesh is essential for volume analysis, material behavior modeling, and design optimization. Because of these, 3D meshing is done on the components. Now to check the quality of the 3D hex elements. Go on 2D, then click on Auto Quality and choose 3D. Here you can check the quality of the 3D elements of HyperMesh by simply dragging the arrow up and down. Here are all 3 meshes are done. Thank you for your patience.